In this video, we'll be exploring how metals are used for many different purposes. Metals are one of our most valuable resources, but what influences the wide range of properties? How do scientists and engineers choose the best metal for the job? We choose materials for particular uses because of their properties. There would be no point making a frying pan out of something with a low melting point, like the metal mercury. The pan would melt when you put it on the hob. Metals make up over 75% of all of the known elements. In the periodic table, you'll find that there is a massive section in the middle of the table called the transition elements. They're all made of metals. On the right-hand side, you'll see a zigzag line. The zigzag line in this diagram separates the metals on the left from non-metals on the right. Hydrogen's a non-metal, but it's often put in the middle. Some typical physical properties of metals include high melting points, which makes them great for electric fires, good conductors of electricity, which makes them great for electric wiring, and good conductors of heat, which makes them suitable for use in cookware. They are high density, so they're quite heavy. Metals are malleable, so we can turn them into ornaments, and they are also ductile, so we can stretch them into wires. Some metals, however, have atypical properties that we don't really expect them to have. Now, mercury has a low melting point and exists as a liquid at room temperature. Elements in group 1 have low melting points, but these metals also have low densities. For example, sodium is less dense than water, and so it floats. Metals typically have a high density, which means they have a high mass for their size. Take, for example, the volume of liquid that you would find in a can of drink, 330 milliliters. If a can was filled with sodium, then the can would have a mass of around 320 grams. However, fill that can with lead, and the can would have a mass of nearly 3,750 grams. That's nearly 4 kilograms. Metals are typically malleable. Malleable substances can be bent or hammered into shape without shattering. They're the opposite of what we call brittle substances. Brittle substances, like glass, shatter when bent or hit. Metals are described as ductile. Now, ductile means that you have a material that can be drawn out into thin strands like wires. All you need to have is a clamp on one end of a metal and a clamp on another end and separate them out. The material in the middle thins because you have layers sliding over each other. Metals are useful for making bells. Bells make a ringing sound when they are struck. The name of the property that is given to a material that makes a ringing sound when they are struck is called sonorous. Some metals are magnetic. A magnet is any object that has a magnetic field. It attracts ferrous objects like pieces of iron and steel. Some metals also exist that are not iron in nature, for example, nickel and cobalt, and they are magnetic too. In the early days, the Greeks observed that the naturally occurring lodestone attracted iron pieces, and from that day onwards began the journey into the discovery of magnets. To explain the properties of metals, we look to see how they bond together. Although we represent metals with a single symbol, such as Cu for copper, we know that it will be made up of many copper atoms. When metal atoms bond together, they are held tightly by electrons. These electrons come from the outer shells of the metal atoms and hold the atoms together like a glue. All of the properties of metals can be explained based on this model. For example, metals are hard and strong because the atoms are held together so strongly, and they are malleable and ductile because you can push against the layers of the atoms and the electron glue will move with them, holding the atoms together in the new arrangement. Metals conduct heat well because the atoms are held closely together, and they conduct electricity well because the electrons in the glue are free to move and carry the electrical current. You can refer to the metal atoms in this situation as positive metal ions. An alloy is a mixture of two or more elements where at least one element is a metal. Pure metals are arranged in a regular lattice where layers can slide over one another. The more difficult it is for the layers to move, the stronger the metal. Different elements have different sized atoms, so when you mix another element with a metal, it disrupts the regular arrangement of atoms. The atoms are no longer aligned in neat rows, which can easily slide over each other, and this makes alloys much stronger and harder than the pure metal. You should now be able to answer these questions. Why not answer them in the comment section below? Have a look at some of the answers that have already been suggested. Why not comment on those answers to say whether you support the ideas or not? I hope you've really enjoyed this video. Please leave it a like and don't forget to subscribe to the channel for more information about features that you need to concentrate on in Key Stage 3 Science. Take care of yourselves. Bye.